Greetings, everybody, wherever you may be, and welcome to French Guiana once again, the home of the Ariane family, for today's launch of Arianespace flight number 205. The first Ariane 5 of this year and the third ATV going up tonight. Joshua Jample here, along with Luca Chiecchio. Luca is from Arianespace's Commercial Directorate. Hello, Luca.
Hello, Josh, and good evening to our listeners that have decided to follow tonight's launch for this exciting mission, the launch of the Edoardo Amaldi ATV. The launch tonight is planned at 1 o'clock, 1:34 in the morning, local time, and everything is going very well.
We're coming to you direct, as we always do, from the Jupiter Mission Control Center, which is the nerve center of the space base. And here, representatives from the three parts of Europe's space teams are working at their command posts. We'll be back with more of the mission, but first, some opening words from Jean-Jacques Dordain, the Director General of ESA.
We are here in Kourou for a third major rendezvous in 6 months for the European Space Agency. 6 months ago, we came for the first launch of a Soyuz with the first two Galileo satellites, then the first launch of Vega, and today, launched by Ariane toward the International Space Station, the third ATV, called Edoardo Amaldi. You can see that the family is now complete, with Soyuz, Vega and Ariane. And the ATV families as well, since this is the third, only a year after the second. This shows we are capable of launching this vehicle, the heaviest ever made in Europe, and the most intelligent also, because it rendezvous and docks automatically with the space station. The fact that European industry can every year build an ATV and then launch it is an industrial feat that I wish to honor.
C'est un exploit industriel que je souhaite saluer.
Outside, Ariane 5 waiting on the pad. The 61st Ariane 5 to fly and the 205th Ariane to go since the program began back in 1979.
Here we are, some 14 minutes from the launch, and as you can see, all the greens are green. The status panel shows that everything is going fine. That means that all the systems are go for tonight's launch, and that the operations are proceeding perfectly well.
These green status panels are a real-time summary of the different launch services provided by the base. We check them from time to time during this first part of the mission before lifting off. All is as it should be.
And here we have Mr. Jean-Yves Le Gall, chairman of Arianespace. What we've seen is actually the flight cell, the cellule de vol. It's made up of the management of the European Space Agency, Arianespace, CNES, Pierre-François Beneteau, the vice president of Kourou.
The Kourou arm.
Edouard Perez, the chief technical officer of Arianespace.
And the living technical memory of all Arianespace flights, I would say.
These are the people who take all the final decisions concerning the launch.
Anything untoward coming up, you'll see them on the phone making the decisions on events to follow. With them, Michel Aymar on the CNES side. The first launch of the year we mentioned, and the 205th Ariane to fly in all, Ariane riding on a string of straight successes.
And here we are in a few seconds. We'll have a short film on the ATV program, so please stay with us and we'll be right back.
The Edoardo Amaldi, in honor of the Italian physicist, is the third in the ATV program. It follows the Jules Verne in 2008, which paved the way, proving the vehicle's advanced automated rendezvous and docking techniques, and the Johannes Kepler mission last year. Flying ATV3 1 year later has been a major challenge. The Kepler flight evaluation had hardly ended, and the Edoardo Amaldi was already en route to be shipped to Kourou. Now that the shuttles are no longer flying, the Russian Progress, the Japanese HTV spacecraft, and particularly the ATV, have a crucial role in resupplying the International Space Station. New vehicles are planned, but the ATV will remain the most versatile of all these visitors, capable of taking the largest amount of dry cargo and fuels, and as an integral part of the orbital complex, responsible for maintaining its orbit and maneuvering to avoid space debris. Practically 6.5 tons has been loaded on the Edoardo Amaldi, 2.2 tons of dry cargo in its carrier racks, and in its reservoirs 280 kilos of water, 100 kilos of oxygen and air, 860 kilos of propellants to be transferred to the space station, and more than 3 tons to control the attitude and to reboost the orbital complex. The dry cargo includes clothing, spare parts, equipment, crew personal belongings, no doubt surprises from their families, and a few of the container bags loaded only a few days before launch will have fresh food.
Food is of course a nice thing to receive in the station, and especially fresh food. We have all kind of good food, very tasteful, but it's always nice to have real tomatoes, a real orange. So that's something we will look forward to.
The Edoardo Amaldi will remain attached to the ISS for almost 6 months, undocking late August. Hardly will it have burned up in the atmosphere, but ATV4, christened Albert Einstein, will be preparing for its own mission to service the ISS.
The European Space Agency is responsible for the flight today as a joint effort with Arianespace and CNES, which was the same for the first 2 ATV missions. You wanted to say something about the launch base, and you had an analogy with an airport, which I thought was very apt.
Well, the Jupiter 2 Mission Control Center is a nerve center of the launch base. It's got the same sort of role as an airport tower would have. It checks out, it verifies that the launch vehicle is doing well, that the ATV, the passenger, is going well, that the support needed for the launch, flight safety, tracking radars, ground range tracking stations, and all that is fully operational. The launch vehicle is on the launch pad some 13 kilometers away from here, being prepared by the launch teams in the Launch Control Center, 3 kilometers away from the pad.
We're going to go up there in just a minute with the camera.
That's right.
And you can see closer up.
And if all these systems are good and great, then they have authorization to go ahead.
Weather's been pretty good all week, not much rain. I don't know if you can see, but the night skies are pretty clear. We should have some fine shots at liftoff, maybe even see booster separation. We're going to look at the presentation of the launcher now. She stands roughly 50 meters tall. In 2 parts, Ariane 5 is. They call them composites here. The lower composite, the 2 boosters strapped on the side, you can see, to the main cryogenic stage.
And tonight's version is an Ariane 5 ES, a version with a second stage, an EPS second stage with a MMH and NTO, which is actually storable propellants, and not the Ariane 5 ECA with liquid oxygen, liquid hydrogen. That's because the ES responds to the need for ATV mission with a reignitable second stage.
And that second stage making up a part of the upper composite, along with the fairing, single engine on the upper stage, and inside the fairing, of course, the very heavy, nearly 20 tons, payload of the ATV. And there's a little mock up there just on the left, here in Jupiter. Looking down into the commercial side now, showing you some more of the key players responsible for the launch. This is where you are usually sitting.
That's
when
right.
When you're not broadcasting. These are the commercial interfaces with the customers from Arianespace.
Nico Detman from ESA. These are the people responsible for the program.
We're going to come up on the in the 7-minute mark in just a minute. You'll hear the DDO, the Range Operations Manager, who calls out all the milestones. He'll be calling out the 7-minute mark, which will be the beginning of what is called the synchronized or automatic sequence, which is what? A complex series of operations running right down to liftoff.
That's right. The very last operations for the launch are run by 2 different programs. After one of the
2
launch
computers, no?
Yes. And they run the final operations, the top-ups, liquid hydrogen, liquid oxygen, so the main core stage, the last pressurizations of the tank, the launch vehicle arming, last verifications on all the electrical systems. They put the launcher in flight configuration, and they start out the final ignition sequence after
And
that.
They also make the launcher
À
more
tous de
autonomous.
DDO, attention pour la séquence finale lanceur.
There's the DDO going to call out the 7-minute mark.
Top H0 moins 7 minutes.
All right, we're in this final tip of the iceberg, the final moments of final countdown, if you will. Power's passing from the ground, which controls the things now, less and less as time goes by. Power switching to the onboard computers, which will make Ariane autonomous.
As time goes on in this second synchronized sequence, the sex scene, the launch vehicle will take over all the functions and become completely autonomous until liftoff, and of course, all during its flight. Now, should there be any issue that would make an interruption of the sequence, we would have to start the sequence again at -7 minutes.
1,001 things to check by these two computers, one doing the fluids, the other doing the electrical systems. We mentioned we have a camera up closer to the launch pad. There are other teams working tonight, about 1,500 people on launch base in all. But one of the places where other people are working is up closer to the pad at the Launch Control Center.
And here we have Christian Lardot, the launch operations manager, with his team. They are doing all the final operations that will bring the launch.
Very busy up there, as you can imagine.
The second team, the technical authority with the Ariane production project manager, they are there to verify that the launch vehicle is in conformity and everything is being done in the right way.
Now, continuing with your airport analogy from earlier, Luca, you can call these people the pilots up until liftoff, I guess. Huh? After that, Ariane 5 flies on her own.
Exactly.
5 minutes away from launch of this first Ariane 5 of the year, the 61st Ariane 5 in all. A word on the weather. We had a first weather check at -10 minutes. We'll have another in about 1 minute. And we'll give you the report. The 10-minute check was A-OK. And we expect the same from the 4-minute check. You have some more time. You can mention, give us a rundown on the green status panels again in more detail.
Well, let's see some more details. So, as I said, this status panel highlights in green when a system is go. If we start from the very bottom, we have the status of the passenger, ATV3 Edoardo Amaldi. He's ready to go. He's green. Up on top of him, we have the launch vehicle, le lanceur, and l'ensemble de lancement, which is the launch base. Now, if we start from the top, we'll have the état de la base, that's the launch base in the whole globality. We see safety, sauvegarde, flight safety, meteo, which is the weather. So the weather is green, no problem tonight with lightning. And we have the measures, telemetry, localization. What's that? That's the tracking radars, that's the ground stations, which have to bring back the data as the launch vehicle flies, because we analyze the data, see if it's working well, and the telecommunications to bring back the data from the ground stations.
You mentioned lightning. Ariane can fly in the rain, which is not a problem. However, there are certain constraints like lightning.
There are two typical constraints. One is speed of the wind, high-speed winds, and the second is lighting criteria. And this is taken into account by avoiding launches close to storms or in certain type of clouds, such as convective clouds, where you might have lightning.
Back in Jupiter, we're going to go to a presentation of the satellite. You look under the fairing there. We showed you close-up of the launcher. That's what things look like underneath the fairing, where you have the very heavy Edoardo Amaldi going to bring much-needed food, water, and supplies to the ISS and bring down some used items and other garbage which will burn up in the atmosphere.
And a very big spacecraft, as you can see. It's practically the size of a double-decker bus that you'd have in London.
The first of the ATVs to be processed and launched within the target cadence of 1 year. The first two, I think, missed that, but Edoardo Amaldi doing fine, carrying the largest and most sophisticated flight software ever developed by the European Space Agency. The total mission for this ATV will last 171 days. She'll be docked with the space station for roughly 6 months, which I think was the case for Kepler, the ATV2. You see these, what look like radio towers, the 4 of them, around the Ariane 5. Those are not radio towers. Those are lightning rods, actually, because we mentioned the lightning being a delicate element.
You have to remember that the two solid boosters they have 240 tons of powder. So we're very careful with that sort of thing.
Coming up on 2 minutes before Arianespace Flight 205 begins, a moment of, what would you call it? You've been down in the fishbowl more often than I have. A moment of intense concentration, focused at 2 minutes before launch. How would you describe the atmosphere?
I would say really an intense concentration. You're in the hands of the synchronized sequence. The two routines are running. Everything's going well, but a lot of things can happen. You follow up all the steps to be sure everything's going well, and you cross them out one by one as they go through. So I'd say people are calm, they're confident, but it's always an intense moment.
A minute and a half to go. You'll see shortly the invited guest here will rise and go out to the terraces. There are terraces on either side here of Jupiter Mission Control with fine view of the launch base, which is, as Luca mentioned, just 13, 14 kilometers away from us here. The DDO is going to call out the 1 minute mark.
DDO, attention pour H0 moins 1 minute. Top H0 moins 1 minute.
So the DDO has called out the -1 minute. Here we go. We're getting into the final ignition sequence. Very close.
Now describe the ignition sequence for us. What do we watch for?
Well, this evening we're not flying an Ariane 5 ECA but an ES, so we won't see the retraction of the cryogenic arms because they're not used. But what we will see will be the ignitions of the Vulcan 2 hydrogen cooling gas igniters at around -5 seconds. That's at the base of the thruster of the Vulcan 2.
Let me just stop you because you mentioned the cryo arms. Those are those yellow bars there that are folded that you can see right in the middle of the screen.
Exactly.
Normally they're feeding the upper stage. Tonight they're not because we're not using that version.
Then a zero ignition of the Vulcan 2 followed by verifications and liftoff with ignition of the SOBs.
Attention pour le décollage. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage Vulcain. Allumage confirmé. Top, allumage EAP, décollage. Tous les paramètres à bord sont nominaux.
Well, we lost her to the low clouds early, but in a blaze of light, there she is coming back out of the clouds, roaring off the pad. The DDO says everything is normal, propulsion and trajectory. In a blaze of light and a trail of gold as Ariane 5 reaches into the skies above French Guiana on her way to deliver ATV3, which will make her way to the International Space Station next week.
We've lost her through the clouds. So the launch vehicle first clears the pad in a vertical rise. And you can start hearing the noise. And the launch vehicle has just passed Mach 1. It's past the speed of sound. 6 kilometers in altitude, 317 meters per second.
773 tons at liftoff. She's burning 5 tons of fuel every second, 2.5 tons in each booster. Those are the big flames on either side. And the EPC, the core stage, in the center is burning another 300 kilos per second. Ariane following the program in the onboard computer, which gives all the orders, including stage separation, which we will soon see, because the boosters and the first stage are burning now, and the boosters will burn another maybe 20 seconds and then get the order from the onboard computer.
In all, they will burn for around 2 minutes, and they will deliver 90% of the thrust at liftoff.
Boosters burning their 240 tons in just over 2 minutes. You can see the 3 points of light there, the 2 on either side. If they come back, it looks like we lost her to the clouds again. 2 on either side are the boosters. Luca, on the left, on the upper left of the screen, there's a cursor, and on the bottom left, A and V.
That's
What are we
right.
seeing?
The altitude. We are at 63 kilometers already, 2 minutes and 20 seconds, and we are at 67 kilometers from Earth.
Séparation des EAP,
And the
les
DDO
étages d'accélération à poudre.
just called out the successful extinction and separation of the boosters. You see what that looks like? There's one on the other side out of camera range. Dropped right on time and on target. Before the boosters are empty, their push diminishes, and this is what the onboard computer senses, a drop in
Les
acceleration,
paramètres de propulsion
and
et
then
de
it
pilotage à
separates
bord
them.
sont normaux, le vol est calme.
Separation occurs 1 second after the onboard computer has detected this speed loss. Did you mention the altitude and the speed?
Right, so the speed, as you can see, 2.24 kilometers per second, not per hour. And if we look at the curve is a projection of where it should be, and the dot is the actual position of the launch vehicle. So as long as the dot remains on the curve, everything is going very well.
So it's real time superimposed on optimal, a real trajectory superimposed on the
Les
optimal.
paramètres à bord sont normaux, le pilotage est calme.
Okay, we're waiting for the fairing jettison.
So the
should
fairing is
be-
a 17 meter by 5.
Séparation de la coiffe.
We've had
L'altitude de vol
separation
est
of the
déjà
fairing.
supérieure à 100 km.
You can see how that happens. There are two halves, actually. The other is out of camera range on the other side. Blown away by what? A series of pyrotechnic cords, I think.
That's right. So it's actually a very light structure, although it is 2.4 tons, but it's 17 meters high, 5.4 meters wide. It's carbon fiber sandwich around aluminum honeycomb, and it protects the payload from the dense atmosphere as it goes through. Then once we get out of this dense atmosphere around 100 kilometers up, we don't need the fairing anymore. So we have a vertical separation system, a horizontal separation system, and they break the fairing in two at the separation.
We don't need it. It's just dead weight. Why not get rid of it? Back with more of the mission in a moment. But for now, the
Les
latest
données
news
issues de la télémesure du
from
lanceur
Arianespace.
sont normales.
On February 13th, the European Space Agency successfully launched the first Vega vehicle from French Guiana, orbiting 2 scientific satellites and 7 small satellites for European universities. This historic mission now gives Europe a full family of launch vehicles and provides Arianespace with the world's widest range of commercial launch services.
At the World Space Risk Forum in Dubai in February, Arianespace reaffirmed its commitment, now 27 years running, to telecom operators in the Mid-East. 3/4 of the satellites here have been launched by Arianespace.
On February 2nd, Arianespace and the European Space Agency signed an agreement to launch another part of the vast Galileo constellation in 2014 and 2015 by Ariane 5. Launch of these satellites will complete the deployment of the Galileo fleet. All 26 satellites will be orbited by Soyuz and Ariane from the Guyana Space Center.
The Satellite 2012 conference took place in mid-March in Washington, D.C. Here, Arianespace confirmed its position as the global reference for the world's top satellite manufacturers and operators. Here, Arianespace signed 2 new contracts, one for the launch of Jabiru-1 for the Australian operator NewSat, another for Eutelsat 25B SHailsat-1 for Eutelsat and its partner in Qatar, SHailsat.
Tous les paramètres à bord sont normaux.
There's
Il reste
the
moins de 3
mock-up
minutes de propulsion
of the
repassée.
ISS, the space station here in the hall, which is sitting next to the mock-up of the ATV. We'll have more on that in a moment. We've
Le
had
pilotage est toujours calme.
we've had signal picked up by our first downrange tracking station. That's in a boat in the Atlantic.
We use 5 ground range tracking stations for this flight. We need them to recuperate the launch vehicle data during a flight, which is sum of part verified in real time to see that the flight's going well, and the other is verified after the launch in greater detail to see that everything is also going well.
Tous les paramètres à bord
Film on the launcher campaign now. You'll see the Coel, you saw him earlier, Christian Lardo. The launch campaign started on November 2nd last year in the Launcher Integration Building called the BIL. These operations were overseen by Astrium, who assembles the Ariane 5.
During the integration phase, the main cryogenic stage was erected. It was then assembled with the 2 solid rocket boosters and then the upper stage with storable propellants. The latter is only used with the Ariane 5 ES version of the launcher, which is used for the ATV program. We carried out mechanical integration and functional checks. Electrical and fluid connection were established and an overall check was completed to validate the launcher integration. This phase was completed last December 17 in the launcher integration building when the launcher was handed over to Arianespace. 2 days later, the launcher was transferred to the final assembly building.
The campaign then continued with a phase which allowed the customer to access the ATV, now integrated atop the launcher, to carry out vital operations inside, like loading the cargo. Then the ATV was encapsulated under the fairing, the upper stage was filled with propellant, and altitude control systems were put in place.
Finally, after completion of final preparation operations at the BAF, the launcher was transferred to the launch zone.
Eight minutes and 12 seconds into flight.
Tous les paramètres à bord sont normaux.
Everything is going on well, and we're getting close to the second event, the extinction of the EPC with its separation, and then the EPS stage. So the EPC, 30 meters long, 4.5 meters
Les
wide.
paramètres de propulsion et de pilotage à bord sont normaux. Le vol est calme.
Everything okay, he's saying.
And a total mass of 278 tons, with only 14 tons of dry mass, and the rest is all propellant, liquid oxygen and liquid hydrogen. A thrust at liftoff of 136 tons, and a flight time of some 8 minutes and more. So we're getting close by.
Which is coming to an end. You'll hear the DDO call out the extinction of this core stage. We're waiting for confirmation of that.
sur commande de guidage.
And there it is.
There it is. So the EPC stops once
Séparation de l'étage principal cryotechnique, le PC.
separation of the stage, as we can see.
You can see how that happens there. There's 3 commands given in the space of about 12 seconds. The extinction of the lower
Première
stage,
allumage de l'EPS.
the separation of the lower stage, which you can see, and then
Tous les
finally
paramètres à bord sont
the
nominaux.
ignition of the upper stage. Our speed, as you can see, 7 kilometers per second. Our altitude, 100 and coming up to 140 kilometers.
And now the EPS is starting to burn. We'll have 3 burns for the EPS. It's a small stowable propellant stage, and it will give us the 2 burns, the 2 burns necessary for the mission, and a 3rd burn to deorbit it at the end of the mission.
Would you say that's the role of the EPS, the upper stage? Does that sum it up, or is there more?
The EPS is interesting because it's a reignitable. We have to put the ATV on a circular orbit, and this is what we can do with an EPS. But you can only do that if you have a reignitable stage, which is so. So the first burn will take around 8 minutes and 11 seconds.
Les paramètres de propulsion et de pilotage à bord sont normaux. Le vol est calme.
And everything is going well. Then the second burn, after a very long ballistic phase, will give the necessary impulse and speed to make a circular orbit, and after that we'll have the separation of the ATV.
Separation of ATV coming up at about 58, 59, no, an hour. Plus 1 hour, roughly. So we have some time to wait. Going to next film now, a new series of films looking at the different space professions held by Arianespace specialists. We'll be back.
Bonjour.
Good morning. Since Soyuz and Vega have begun using the CSG for their launches, the profession of the industrial prime for launch site operations has taken on importance in Arianespace daily activities. We have performed these duties for the past 30 years for the Ariane launch site, and today we have extended them to include Soyuz and Vega. So what exactly does the job entail? It covers activities on the countdown day, but in fact it's something that we do every day throughout the year when dealing with maintenance or with operation launch systems. It also entails some specific duties, typically overseeing the filling of 4 cryogenic tanks at the same time, if you are using an Ariane 5 ECA. This is a unique operation. It's linked to each customer's needs, as it involves the satellite integration on the launcher. We rely on Arianespace teams for these activities and also on a consortium from industry of some 500 people, all experienced and competent in their areas of work. In a series of short films that are going to follow, you will meet some of the people who do these jobs and learn about their work. We begin with Christophe Melin, one of the best in his field, the storable propellant stage.
I'm what they call an EPS expert, and therefore have to carry out a series of preparation and control operations for the solid booster stage. During the campaign, we begin with the preparatory phase for the different operational procedures that correspond to the specific nature of the stage. We then move on to the operations themselves that can take place at different sites, such as the BAF, which is the final assembly building, or in the launch zone. Today we're preparing for the SCA filling operations. We're in the process of connecting all the interfaces between the ground facilities and the launcher, which allow us to fill the SCA with hydrazine. We're working in the launch zone with teams from groups like Astrium, who have perfect knowledge of the launcher, and Sedgelec, who are fully versed in the ground processes. Our role as Arianespace operations engineers is to be the interface between all these teams and to carry out the operations nominally and smoothly. We have other operations that can be carried out remotely on the workstations at the launch center. Today we're carrying out the filling of the EPS with MMH, that's monomethyl hydrazine. It's a rather dangerous operation using a toxic propellant, and it takes 7 hours. The tanking team is equipped with special protective clothing, and I'm at my workstation to manage this procedure remotely. Next, we move to the launch countdown, and I'm part of the launch countdown team, in part of a specific subsystem. After the launch, we carry out a level 0 post-launch analysis, check all the launch parameters so we can use them optimally for the next launch. An EPS engineer needs to have technical expertise in areas such as thermodynamics, fluid mechanics, and hydraulics. He should also enjoy teamwork, because he has to work with teams from industry. His other qualities should be to be available, open-minded, and ready to take on board comments made by colleagues with knowledge and experience in their different subsystems. So listening to them is vital. I myself began with Arianespace as an operational engineer, initially on the cryogenic stage. Then I moved on to the EPS. I've been in Kourou for the past 2 years, and my area of responsibility has now expanded and includes ground segment procedures related to the launcher. As a member of the technical authority team, I also have some special engineering duties. Today, with Soyuz and Vega launches taking place in Kourou, we may be called upon to work on their launch zones, and I personally could be involved in Soyuz frigate and Vega's Avum stages. What I particularly like about my job is that it's hands-on and varied, not at all repetitive. It changes from one campaign to the next, and we can work on different sites and different systems and activities, which makes it all the more exciting and all the more challenging. During the film there, we were picked up by our second downrange tracking station. You can see it there. It's in the Azores in the North Atlantic. Santa Maria, it's called. You wanted to say a word about the different propulsion systems on Ariane 5, because we have solid propulsion in the boosters and cryogenic propulsion in the upper stages.
Oh, the main core stage, and then we have a storable in the upper stage. For this version, we have 3 different propulsion systems. They're solid rocket boosters, the AP. They use 240 tons of powder. They provide 90% of the thrust at liftoff. A total liftoff thrust of 600 tons. It allows us to lift this massive launch vehicle and takes it out of the dense part of the atmosphere. Then the EPC takes over, very efficient cryopropulsion, a thrust of 136 tons, burns for some 534 seconds, and it positions the launch vehicle in an
Les
intermediate
paramètres de
orbit,
propulsion et de pilotage à bord sont normaux. Le vol est calme.
just before the EPS took over. The EPS, small, stowable propellant stage, 9.2 tons of thrust, but with a reignitable capacity. So this will allow us to position the ATV exactly where we need to position it on a circular orbit that it requires just before separation.
You mentioned the cryogenic stage was efficient. Does that mean it's more efficient than the solid propellant?
The use of
Première extinction de l'EPS et début de la phase balistique qui va durer un peu plus de 42 minutes.
Before you answer, the extinction of the first burn in the upper stage has just happened. You can see the engine shut off. So we're coasting now. Before we talk about coasting, answer my question about efficiency in propulsion systems.
the cryo propulsion is much more efficient. If you use liquid oxygen, liquid hydrogen, you'll have a much more efficient motor and engine. So that's the reason. However, it's more difficult to reignite. So an EPS is easier to reignite, and that's exactly what we needed it for.
Okay, so we are in a what they call a ballistics phase. Also, I think a barbecue phase, which you can see because the ATV is turning on herself. Why is it turning?
We're going to have a very long coast phase, and some parts of the spacecraft, or the upper composite, what remains of it, it may be contact with the sun. So to equalize the thermal loads, you put the upper composite in a very small roll mode, what we call barbecue, so that you don't have a same point always aiming at the sun and another point always in the shade, which would create a disequilibrium in the thermal loads.
All right, so the ATV spinning up, you can see what's left of the composite of the 773 tons. You have the 20 tons of the ATV and the various adapters and the rest. 26 tons maybe.
On the very bottom ring, what we see there, you see the EPS, and you see what remains, well, the other ring is the VB, the vehicle equipment bay, where all the, let's say, the electronics of the launch vehicle is situated.
In the coasting phase, we're awaiting a word from Jean-Yves Le Gall, Arianespace Chairman and Chief Executive, who I think is going to declare the ballistics phase operational. So until he speaks, I think he is coming to the podium out here on the other side of the fishbowl. Mr. Le Gall.
Well, as you have just seen, the first part of the mission is now completed, and we have now begun the ballistic phase. The EPS, which is the storable propellant stage, which has been manufactured in Bremen, is now crossing Europe. It'll go over Asia and Australia, and will work for approximately 27 seconds beyond that. And then 2 hours, 7 minutes, 49 seconds later, ATV3 Edoardo Amaldi will be separated. So in approximately 40 minutes, I will meet you again to move on to the second part of the mission.
A film, next film? Luca?
Yes, a film on the ATV cargo. And we'll be back with you right after the film.
Since the end of the shuttle flights, Europe's automated transfer vehicle, ATV, is not just the largest space ferry to the International Space Station, it is also today the world's heaviest spacecraft, now embarking on its third mission. Since its arrival in Kourou last August, ATV3 has been loaded with dry cargo, gases and fuels. Before the 2 sections of the spacecraft were mated, the integrated cargo carrier module was packed brim full. About 100 bags were securely fitted into its 8 supply racks, 2 more than on the first 2 missions. Each item, bar-coded for easy identification during unloading, was optimally placed to distribute the mass in the carrier section. The ATV3 manifest includes fresh food, clothing, supplies, spare parts, experiments, and memorabilia in honor of Edoardo Amaldi, the visionary Italian physicist, including a letter that he wrote in the late 50s to a colleague in which he envisaged uniting Europe's space efforts. Last January, the fully assembled spacecraft saw a series of delicate fueling operations. This included some 5,400 kilograms of fuel to control the attitude of the International Space Station and to reboost it higher, plus 860 kilograms of fuel that will be transferred to the Russian segment of the orbital complex. 100 kilograms of gas, air and oxygen were also pumped into ATV3's reservoirs and 280 liters of drinking water. But loading was not complete. The ATV's late loading possibility has been greatly improved, doubling the amount of supplies that are lowered only a few days before launch into the freighter's pressurized cabin through the craft's forward hatch and docking port. Until now, this was limited to items with a maximum mass of 30 kilos, but special equipment and procedures have been developed to allow an item of about 60 kilograms to be inserted, a NASA water recycling unit required aboard the space station.
Since the stock of potable water on the ISS is not infinite, and they need either to bring new potable water, which the ATV is doing, by the way, also in parallel, but also to be able to reuse, to recycle the wastes which are generated in orbit. And this is just the normal life aboard the space station.
In all, about 60 bags, some 530 kilos of last-minute items were loaded, once again proving the ATV's capacities and versatility as a space freighter when the amount of cargo of all kinds is totted up. The Edoardo Amaldi will be carrying another record-breaking amount of supplies, nearly 7 tons, to the ISS.
Luca, you've done some research on this man, Edoardo Amaldi. What have you come up with?
Edoardo Amaldi was a leading figure in Italian science in the 20th century, particularly in fundamental and experimental physics. He contributed to nuclear physics in the 1930s and 40s with a group led by Enrico Fermi, the Ragazzi della Via Panisperna, which was the name of the street where the university was situated. In the post-war years, he worked on cosmic rays and particle physics, and in the 70s he became a pioneer in the experimental research of gravitational waves. So it's largely thanks to his drive that Italian physics emerged successfully from the slump following the Second World War. But we'll tell you no more after the next film, the ATV Edoardo Amaldi campaign.
The campaign lasted for 6 months, which is in keeping with the nature of ATV, a veritable giant in size and the volume, and the scale of the facilities at the base that were involved.
These 6 months began with arrival of the ATV at the nearby port of Pariacabo. It was transferred by road to the satellite preparation building, where its solar panels and pressurized module were integrated. During this phase, many verification tests and checks are carried out. If all are positive, we get the green light to move to the next phase of operations, filling the ATV with its propellants. When these have been completed, the ATV is moved to the final assembly building, where it's integrated atop the Ariane 5.
This brings us to an end of 5 months of preparation. We are now going into another world, that of the launcher and the combined operations.
Combined operations take place in the final assembly building. Here the ATV is mated atop the launcher. Then its cargo can be brought aboard. This phase is known as the late loading operations, and they are unique to the ATV. After the cargo has been stored aboard the spacecraft, tests make sure it is airtight. A full 24 hours of tests and checks must be carried out by the Astrium teams to ensure that the ATV and the Ariane 5 are ready for flight.
And naturally, we end with the encapsulation, and this is our last view of ATV after months of campaign. With ATV3, we have reached a certain maturity in organizing our operation. We have something of a routine, which is recurrent. Some of the team members were part of the previous ATV missions, and therefore can share their knowledge and experience with others. They remember past campaigns quite well, and this enables us to continuously optimize every aspect of the campaign.
Et à ce point-là, d'optimiser encore et encore la campagne.
You left off with the Edoardo Amaldi story at the nuclear physics with Fermi, I think you were talking about.
Right, but really the major thing that he was convinced to be on the cutting edge, Europe had to lead projects on a European scale, with collaboration between the different European countries. Thus, he was also one of the main players in the process that turned the dreams of a large European scientific project into reality. As such, he contributed to the creation of the CERN, le Conseil Européen de la Recherche Nucléaire, and ESRO, the European Space Research Organization. And ESRO, as you know, gave place to ESA.
Became ESA in 75, I think, where they merged ESRO and the other one was ESRIN, I think. No, I might be wrong about that. We'll check it. A film on the relationship between Arianespace and ESA coming up. Now, back with more. ATV-1, called Jules Verne, was launched in March 2008. 3 years later, ATV-2, Johannes Kepler, was launched by Ariane. Launch of the third, Edoardo Amaldi, comes only a year after ATV-2 and takes the program into a new era.
Edoardo Amaldi is a showcase in many ways. It confirms that Europe can prepare and complete such an important mission in record time. It shows how ATV can be supplied by European industries with a quick turnaround time, which gives ESA the advantage of compensating ISS operational costs with the mass of the cargo transport. For this mission, the mass is 6,600 kilos.
Lessons learned from ATV-2 have confirmed both the viability and the strength of the ATV program overall. This experience has allowed ESA to concentrate on its functional and operational aspects while making only a few minor corrections and adjustments.
We worked mainly on first, optimizing operational procedures, and second, improving the cargo loading capacity when the ATV is already in place at the top of the launcher, so that we can react in a more flexible manner to our partners' requirements.
All ATV missions follow a standard pattern, but each has its own particularities and requirements. These are established a year before launch. ESA matches the ATV's cargo load to the maximum performance of whatever launcher is available for the launch date, then Arianespace prepares its launch vehicle for the mission.
It takes 1 year to prepare a standard mission, but for ATV3 we had to adjust to a change in the cargo fairly late. 2 months before launch, ESA informed Arianespace that 250 kilos out of the total 2 tons of dry cargo had to be removed and replaced with 250 kilos of propellant. In only a few weeks, Arianespace had to ensure that the mission schedule was not in any way affected by this. Finally, the swap took place.
The Arianespace teams bring together the finest technicians Europe has produced. For more than 3 decades, they've made Arianespace the world reference in launch service and solutions.
ESA and Arianespace are permanently in touch. Their teams have together prepared the ATV mission on Ariane 5, and it's very special because it's the heaviest payload ever launched by an Ariane 5. Along with ATV, Arianespace has its usual workload with telecom missions, and it's a source of pride that Arianespace can cover such different types of missions with the same level of service.
Edoardo Amaldi, often called one of the fathers of his nation's space program, a program that took a great leap forward just last month and right here with the first launch of Vega. Europe turning a new page in its space history and also a new chapter in for European and international business. This was a qualification flight, not a commercial flight, however.
That's right, it was the maiden flight of Vega, and as a matter of fact, it was done by the European Space Agency, for the European Space Agency was responsible for its qualification. Now, as the launch vehicle has been qualified, it will be affected to Arianespace, as ESA has chosen Arianespace to commercialize this new launch vehicle.
And they're saying the launcher has a big future in the small satellite market.
Okay, for now we have a film on the past collaboration between Arianespace and ESA, a short film on the scientific missions.
Arianespace, the world leader in launch service and solutions, although lead the way in space science. It has contributed to scientific research since its second flight back in the 80s and continues to serve the scientific community. Since then, the Ariane family has launched dozens of satellites, probes, and spacefaring ships that have helped expand our knowledge of fields as diverse as astronomy, the magnetosphere, oceans currents and their circulation, the study of comets, general Earth observation and the environment, and meteorology. These satellites had names like Giotto, Hipparcos, ISO, XMM, Rosetta, Herschel Planck, High-RS, TOPEX Poseidon, and VSAT, the Spot series, and more recently Galileo and LARES. Whether in Earth orbit, sun-synchronous orbit, polar orbit, these valuable payloads have helped place Europe at the forefront of contemporary science. They have given us invaluable building blocks for the future studies of not only our home planet, but the entire cosmos as well.
Three launch vehicles on the equator, as we used to say. Yes, now there's a family of three different launch vehicles, the Ariane 5, Soyuz, Vega. Arianespace has a perfect solution to reply to a wide variety of missions. And as a matter of fact, we're proving that because we're already preparing ESA satellite missions on all three launch vehicles.
Last October, we had the inaugural launch of Soyuz here at the space base, and just last month, the initial launch of Vega. Europe's spaceport continues to grow. The ATV, on its way to the ISS, will show rendezvous and then dock during the night of March 30th. Over to Yannick Descata, now president of the French National Space Agency. He'll be discussing the ATV industrial program.
The third ATV, Edoardo Amaldi, will be launched by the European launcher Ariane 5 from the CNES Space Center in French Guiana, Europe's spaceport. When the upper stage of the launcher will have finished its work, it will be deorbited. This means it will undergo a controlled re-entry and will be burnt up over the South Pacific. During this time, the ATV will be controlled by the ATV Control Center at the CNES Space Center in Toulouse, with ESA and Astrium. The ATV Control Center will start up all the ATV's functions, carry out the tests and maneuvers, which will ultimately allow for the final docking with the station, which will be done automatically. Then in a few months, when the ATV will have completed its mission, the Toulouse Control Center will carry out all the delicate maneuvers, separation from the space station, then re-entry into the atmosphere until the ATV will disintegrate over the South Pacific. All these operations show that Europe fully masters the technology for rendezvous in orbit and automatic docking. And Europe is ready to put up all its capabilities at the disposal of a grand global program to explore the solar system.
So collaboration, and Europe has been a great collaborator in the construction of the International Space Station. European countries have collaborated on the ISS in different ways. Through ESA with projects such as Columbus, and the ATVs, which now we are launching the third. And by providing different hardware such as a cupola, nodes 2 and 3 on the ISS, and as well as 3 MPLMs, multi-purpose pressurized modules, the Leonardo, Raffaello and Donatello, which successfully were used by the Space Shuttle in the past when the Space Shuttle flew. Now a short film on the ATV program by Yastrium.
I'm the Astrium ATV program manager, so basically responsible for managing the complete part of ATV for Astrium, and for each particular mission I'm still responsible for the complete ATV team supporting the mission during flight.
I'm the deputy to Wolfgang as a program manager of the Astrium activities necessary to prepare and deliver the ATV for each flight and supporting each flight of the ATV as well.
ATV is very much exciting. Very seldomly you have the opportunity to work on a project and an element like ATV, and in particular to get together with so many different people all across Europe and to produce such a wonderful element which is doing useful things in space. A lot of people, a lot of boys dream of that. We are allowed to do so.
I fully share, of course, that view of Wolfgang, and we are proud, of course, of having designed such a sophisticated vehicle and to have also the opportunity of building and delivering and flying every year this fantastic vehicle. The fun, at least for me, it's really that we have made from a blank piece of paper a vehicle that is now working well and servicing the station every year, and that we are doing that as Europeans, as we said, every time redoing or achieving that kind of miracle that is to dock and to service the station.
For me, the largest fun or most fun is to work together with so many different people from so many different cultures. It's a challenge, of course it's a challenge, but it's very, very satisfactory if you see the result and if all the parts of the gear are going together and you have at the end what you expected to have. That's very, very big excitement, and you do it with other people. For the further ATVs, we simply plan to be as successful as we were with the first ones. If we can achieve that, at least for myself, I will be very, very happy.
I will be happy as well. And we have one that is ready to fly, and we have still two after to finish, to deliver and to fly as well. So we have still a bit of work in front of us.
The main thing which is changing for us, not having the shuttle anymore, is that there is a little bit more pressure on ATV, and the world or the international partners are a little bit more focusing on the ATV. So we are now in the spotlight, but it's a challenge for us. We appreciate the challenge, and of course we have the benefit as well, being in the focus and delivering what we shall deliver.
We mentioned, Luca, the upper stage burns. There'll be 3 of them, but we didn't go into much detail. The second burn, what's that going to be used for?
The second burn, which will take place in around 20 minutes or so, is actually it's not a very long burn, but it's a very important burn because at the moment the stage is on an elliptic orbit with an apogee around 260 kilometers in altitude, but a perigee at around 135, so it's not exactly what you're looking for. And the only way to do that, to raise that perigee, is to do a short burn at the apogee. But here we go with a new film.
On the city of Bremen, one of the Ariane city's community members.
The launch of the Ariane rocket is a great event and a particularly special experience, especially for us here in Bremen and for me, as the mayor of the city and spokesman for the European cities in which the Ariane has been developed and produced. Here in Bremen, we make an essential contribution to the European space industry with the Columbus module for the ISS, the Ariane and the ATVs. This rocket will now carry the name Bremen and the key from our town's coat of arms up into space. There are many thousands of people involved in this magnificent project, and in my opinion, the European space industry is a shining example of what people can achieve if they cooperate and combine their expertise, competence, abilities, creativity, and above all, their enthusiasm. For this reason, I would like to express my deepest thanks to all the scientists, engineers, technicians, and all those involved in this magnificent project, and wish this project every success today and in the future.
Luca, there's a special adapter for the ATV3. It's called SDM. What does SDM mean?
SDM for Separation and Distancing Module. Normally, it's Arianespace that provides the adapter for the launch vehicle and the spacecraft. In this case, it's ESA that provided the specific adapter. It's a very large, 3 meters and 36 millimeters wide. It's a carbon fiber cylinder bolted down to the launch vehicle on the lower flange, and then the ATV is clamped on top of the upper flange with a metallic clamp band. But here we go with a film on the ATV CCC.
CC for Control Center in Toulouse.
Since the earliest days of spaceflight, the French space agency CNES has accumulated a significant expertise, not only in the conception of satellites and manned spaceflight, but particularly all aspects of spacecraft operations in orbit. The creation of the ATV Control Center, ATVCC, was decided in 1998 and installed in 2002 at the CNES Technical Establishment in Toulouse. It has the responsibility of conducting, on behalf of the European Space Agency, the coordination of all in-flight phases of the automated transfer vehicle. The ATVCC coordinates all the control facilities involved in an ATV mission, those related to ISS operations like the NASA one in Houston or the Russian one in Moscow, not forgetting the astronauts themselves in the International Space Station, and also the ESA Ground Network Control Center hosted in the Columbus Center in Germany. The Jules Verne inaugural flight of the ATV in 2008 required 2 demonstration days to validate the vehicle's automatic rendezvous and docking technology and its collision avoidance maneuvers. The second mission last year with the Johannes Kepler was a fully operational one, the first in a series of recurrent flights. For each mission, the ATVCC establishes with its partners the flight timeline and the complex procedures and validates all the required control systems. After launch, it tracks each phase, including the rendezvous and docking with the ISS. Since the Jules Verne, CNES and ESA geared up to the prospect of these recurrent missions. A training academy has ensured with theoretical and practical classes and intensive flight simulations that all team members, including new ones, are operationally ready. The Edoardo Amaldi mission, coming only 12 months after the last one, has proved the ATV program's ability to respect the tight schedule of yearly flights, reflecting the role of the ATV spacecraft as the primary cargo and service vehicle for the ISS. During the attached phase, the ATVCC will coordinate all spacecraft operations, such as cargo and fuel transfers, orbital maneuvers, and reboosts of the ISS. And at the end of the mission, it will supervise the vehicle's undocking and last maneuvers that safely deorbit it over the Pacific Ocean. The ATV may be highly automated with many built-in safety measures. Teams are highly prepared, yet there will still be tension in the control rooms for each phase of the flight. It will never be a routine job, particularly as human life, that of the ISS crew, is involved.
So as we were saying, the ATV is attached to the SDM with a series of clamps which are held in place by a clamp band. The clamp band is released by a pyrotechnical device, and once the clamps are released, the series of springs inside the SDM push the ATV away from the upper composite. Now a little quiz question from Joshua. Joshua, who has gone downstairs to prepare an interview. The quiz question number 205, and it concerns the ISS. How many elements currently make up the ISS? And here we are. Now Joshua has gone down for an interview with the European Space Agency astronaut Leopold Eharts, so that you'll know everything you wanted to know about the ISS and the ATV while we're waiting for the end of the ballistic maneuver of the EPS. And just before that, we should have a recap of all the events. So the launch this evening, which went perfectly well and on time at the launch intent at 1 o'clock and 34 minutes. Beautiful scenes in the night of French Guiana. The first phase of flight, where the boosters throw 90% of the thrust, then separation around 2 minutes later, and then once we had an altitude of around 106 kilometers, the separation of the fairing. We no longer need it, and we don't want to bring unnecessary weight with us. And then finally, separation of the EPC, extinction, separation, and the startup of the EPS engine. A long boost, which went perfectly normal, very smooth, and then a very long coast phase while we wait to get to the apogee of this intermediate orbit for the final boost, and after that the separation. But please stay with us and let's listen to the interview.
What would you like to know about the ATV, really, or the ISS that you don't already know? Well, we're lucky tonight to have someone who can help us answer those questions. With me is Leopold Eharts of European Space Agency. Leo is an astronaut, and he knows everything about the ATV and the ISS. How does he know? Because he flew for 7 weeks on the ISS back in 2008. And he also flew on the Mir space station, the Russian one, earlier in the decade of 1998, I think it was. Yes, we're going to be visiting with Leo for a few minutes, and we're going to find out more, hopefully, about both the ATV and the ISS. Leo, thanks for being with us.
It's my pleasure.
Can we start with the ATV, and then we'll move to the space station? First question, can you give us a rundown, a description of what the role of the ATV is and what's it used for, mainly?
Okay, let's try to. So the ATV first is a logistics carrier. So it is able to deliver to the station fluid cargo or dry cargo. So when we say fluid cargo, that's propellant, water, or gas like oxygen, for instance. And all this is located on the middle and aft part of the vehicle here. And we also have some dry cargo, and this is crew supplies, food.
Gifts from home.
Exactly, and also spares for the station and experiments also. And all this is located here on the front part of the vehicle, which is pressurized and which will connect to the space station. So after, on the 28th of March, after a few days, after the launch, the ATV will dock to the ISS here and will become a part of the station. So it will be one of its modules during 6 months, more or less. During that time, the crew will be able to offload everything which is delivered by the ATV and load it with the trash and with the things which are not needed anymore.
That's for the mission home.
Exactly. And finally, the ITV will become a part of the station systems. So it will be a part of the propulsion system of the ISS, which is located on the Russian side. And doing that, it will be able to control the attitude, the orientation of the space station, and also to reboost it, means to regain altitude when it's needed.
So it's not only a cargo vessel, but it has other functions, propulsion, as you mentioned.
Exactly. It's part of the building, and it's also part of the systems.
Okay, very good. Now let's leave the ATV and come aboard the ISS, which was your home for over 2 months. You are standing where the ATV is docked. That's in the aft end. That's on the Russian side, I think. I'm over here on the American International side, which is forward. Now take us on a guided tour. What else can we see?
Okay, so in a nutshell, the station is, the surface of the station is about the size of an American football field.
100 yards, 100 meters
yards,
roughly?
Or a soccer field, if you prefer. So the station has, flies at an altitude about 400 kilometers and a speed of 28,000 kilometers per hour.
400 kilometers is what they call low Earth orbit.
That's low Earth orbit, exactly. So the current mass of the station is about 360 tons, and it can deliver 80 kilowatts for the users. So as you mentioned, there is a Russian side here, which is the aft part of the station. When we say aft, this is with regard to the direction of motion of the ISS, which is usually in that direction.
So we're flying this way?
We're flying this way, exactly, most of the time. We have also what is called a US orbital segment, but which also includes the European module, which is here, the Columbus, and the Japanese modules, and also the Canadian robotics. We have this big truss here, which holds the 4 big solar arrays and also 2 big radiators here. And we also have a rail track on the truss, which can carry the robotic arm or other equipment. So this is a big station.
Now you mentioned Columbus. Columbus is on my side here. This is the European contribution to the space station, very important for the European Space Agency. Now part of your mission when you flew in 2008 was to actually set this up. You set up the European module, and you also used the remote Canadian arm, which you mentioned.
Yeah, that's right. I had the chance to be part of the mission which delivered the Columbus module to the ISS. So that was, as you mentioned, on the space shuttle Atlantis, and we installed the module first, of course, and then we installed also 2 external payloads on the top of these external platforms of the Columbus module here. And for the first time, I was able to use the robotic arm of the station for that. Then the shuttle left, and I stayed 1.5 months more on board the station to finish the activation of the Columbus systems and also of its scientific installations. And since then, the station is, the Columbus module is the European laboratory in space, permanent European laboratory.
And the experiments continue.
And the experiments continue today and hopefully until 2020.
I think people want to know about a typical day in space. I don't know if it's that much different than a day on Earth. You wake up, you look for your toothbrush. The difference might be that your toothbrush is floating around.
Yeah, right. It's almost like a usual day on the Earth, but usually the crew wakes up or start to work around 7:30 or 8 in the morning. Then there is a lunch in the middle of the day. We have 2 kitchens. One is here on the Russian service module, and another one is here on the Node 1.
2 different kitchens?
2 different kitchens.
Which one has the better food?
It's about the same. But what is important is about to change the food when you stay a long time in the station. The day usually has also some work on the experimental work for the crew. This is what is done most of the time now because the station is finished, so the crew is doing scientific research and also work on the systems and the maintenance of the station. Besides, we also have physical exercise, 1.5 hours per day, and we have to do also some cleaning, and this is usually done on Saturdays.
You spend your weekends cleaning the space station?
No, we don't spend all the weekend cleaning the station, but it is usually done on the Saturday, but usually the weekend is free.
Okay, last question, and very briefly, of all the time you spent on the space station, what would you call your most memorable event or events?
Well, usually there are a lot of memorable events, but one of them, of course, is when we finished installing the Columbus module. So that was a great moment, and I had the chance to be able to announce that the module was part of the station, finally, and also gave a tribute to all the people who worked on it many, many years in Europe and elsewhere. But I remember also the day when I flew for the first time over my hometown of Biarritz in France, and that was a great moment of emotion to look back at the place where I grew up and dreamt of becoming an astronaut.
And on that moment of great emotion, I'm afraid we're going to have to leave it because we're out of time. We hope you enjoyed our brief interlude with Leo Aerts of ESA, learning about life in space. Leo, many thanks.
Thanks to you. Thank you. Thank you.
Don't go away, because the mission continues. In about 10 minutes, we're expecting separation of the ATV. Before that, you'll hear the second upper stage burn that'll be called out by the DDO. For all that action, we're going to go back to our friends in the broadcast booth now. I can see them moving back up into position. I'm going to be joining them in just a minute. So Luca, Pierre, and Marie-Noël, please, you may go when you're ready.
Thank you, Josh. I'll wait for you to come up, and everything's continuing. Everything's going very well. We've had acquisition of the tracking station by Adelaide, and we should be almost at the end of the coast phase. We'll be waiting here. We see the DDO and the altitude 265 kilometers, 7.42 kilometers per second.
Deuxième allumage de l'étage à propergol stockable, prévu durer 28 secondes.
And here we have the announcement. The EPS has just ignited. Everything is nominal for a duration of 28 seconds. The second boost, which is going to make the orbit circular.
Les paramètres de propulsion et de pilotage à bord sont normaux.
Everything is nominal.
From the fiction novels in the 1860s to Hermann Oberth's first use of the expression space station in 1923, to Werner von Braun's concept in the early 50s of a cartwheel-like structure above the Earth, there have been many projects of a manned orbital station, but which became reality in 1971. A decade after sending the first human into space, the Soviet Union launched its first Salyut station in 1971. 2 years later, the United States placed Skylab into orbit that hosted 3 crews until it was abandoned in 1974. Continuing its focus on long-duration missions, Russia orbited the first modules of the Mir station in 1986. Construction of the International Space Station began with the first 2 modules in 1998, and its first crew arrived in 2000. It has been manned constantly since, with over 200 astronaut visits. From the outset, this orbital outpost has been a project of international cooperation, with the European Space Agency a key partner, together with the United States, Russia, Japan, and Canada. It is without doubt the most complex space program, technologically and politically, that has ever been undertaken.
Into the first stage capture.
ESA has contributed many essential modules, the most important being the Columbus Laboratory, but also 2 connecting nodes, the ERA robotic arm to be added next year, the Cupola viewing tower, and a data management system for the Russian segment of the station. It can be noted that most of the pressurized parts are made in Europe, with Italy building several nodes, the connecting elements between modules. Europe has been a contributor and a user. To date, over 20 European astronauts have visited the ISS, several on long-duration missions. All have conducted a large number of scientific experiments, many having direct implications for everyday life on Earth. They have also acted as educators, providing startling images from space and inspiring youth in frequent link-ups with schools. ESA's ATV program is the latest major contribution, with the largest, heaviest and most complex space vehicle ever produced in Europe. Its regular missions as a cargo carrier and as a space tug to maneuver the orbital complex are essential to the continued use of the station. Since the end of the shuttle flights, the ATV is one of the few spacecraft servicing the ISS. After the Edoardo Amaldi, 2 further ATV flights are planned, a 4th, the Albert Einstein, and then the Georges Lemaitre. After that 5th and last ATV in its current form, avenues are being studied that would ensure both that the program's advanced technologies are used in future projects and to serve as a bartering element in paying for Europe's share of the ISS running costs.
Less than half a minute until separation of the ATV. Again, Luca, one of these moments of high concentration, just like before liftoff. High concentration for everybody here. Tonight representing months, years actually of work for many people here and for people around the world.
Fin normale de la poursuite du lanceur par la station d'Adélaïde.
You can see the mood here among the faces, rather focused.
Yes, we're at this point, we're at the end of the mission, we're waiting for the very last point, the separation.
Séparation ATV3 Edoardo Amaldi.
And it's been confirmed. We've had separation, and it's been acquired by the launch vehicle.
And the applause heralding the good news. Ariane 5 once again delivering, successfully separating her passenger, the ATV3. You see what that looks like up there. Luca explained the spring system, which releases the 20-ton payload. She's on her way now to join the International Space Station. Docking should occur the night of the 30th. Right on target at 269 kilometers up. So the mood, as you see, very buoyant now and all across the Space Center for being focused moments before. We're going to go to one of a couple of launch replays now. You can relive those very exciting moments you saw an hour ago. The handshakes and the cigars will be coming, and the champagne will be popping. Here in Jupiter, we're going to show you a second replay from another site. We have half a dozen observation posts here at the base, and all with different views on the launch zone. We're waiting for the traditional post-launch speeches. We'll be hearing from Jean-Jacques Dordain, the head of the European Space Agency. And we have a third replay for you, even closer up. Look at this.
Just in front of the launch vehicle.
We'll be hearing from Mr. Dordain, the Director General of ESA. And we'll be hearing from Jean-Yves Le Gall, Chairman and Chief Executive Officer of Arianespace. We may be hearing from a minister or two by telephone. That has to be confirmed. I'm not quite sure. But these gentlemen, Messieurs Le Gall and Dordain, will be making their way shortly out from the fishbowl on the other side. There's the teams checking their downrange tracking stations or at their offices. How's the signal? How's the ATV functioning? They'll be joining their way, joining us out here, making their way out from the fishbowl. I see Mr. Le Gall has made it out on this side after no doubt shaking hands with colleagues on the other side. He's making his way to the podium, and I believe he's ready to address the crowd.
Comme vous venez de le voir, l'Europe vient de connaître un nouveau succès avec la mise en orbite parfaite de l'ATV Edoardo Amaldi. Et ce lancement était exceptionnel, d'abord parce que, après le premier lancement de Vega cette année, le 13 février, c'est un nouveau succès pour l'Agence spatiale européenne et donc une étape particulièrement importante pour l'Europe spatiale. Ensuite, c'est la troisième fois que l'Europe contribue à la desserte de la Station spatiale internationale, Et enfin, c'était le second des 12 lancements que nous comptons faire cette année, dont 10 ici au Centre spatial guyanais. Je souhaite donc féliciter très chaleureusement tous les représentants des États membres qui ont assisté à ce lancement, en particulier ceux qui nous ont fait l'honneur.
Particularly those who have been kind enough to come to French Guiana. I would also like to congratulate the Director General of the European Space Agency for his determination to carry out the sort of space policy that every European can be proud of. Because this success, first of all, is the success of Europe. From Germany, for the DLR, which has always supported and been active in manned space flights and enabled the decision to move on to ATV. Italy and ASI, who's played a very important role with the station. France, CNES, that developed the Ariane 5 ES launcher and also ensured with ESA all the operations of ATV's orbit control operations here with the European Space Agency, and of course all the other European states. But this success is also the success of Astrium and the European space industry that developed ATV, which is the most complex spacecraft ever developed in Europe and which can ensure the production of the launcher that put it in orbit. Therefore, I would like to thank all our friends in Bremen who built ATV3 and gave the name of their city to this launch. They did this a few years ago. It brought us luck then, and it has brought us luck again today. Congratulations to you. And this success is also the success of the CSG, the Guyanese Space Center, which has confirmed once again that it is part of the very select club with Baikonur, Cape Canaveral, and Tanegashima, the select club of space centers that supply the station. And it is quite clear that the quality of our installations and also the quality of the service of our international partners here in Guyana contribute to this success. That is the 61st launch of an Ariane 5 and the 47th success in a row. Our mission for now is completed, but we will continue with ATV3 up to the deployment of the solar panels. And in the meanwhile, I have the pleasure of giving the floor to Mr. Jean-Jacques Dordain, Director General of the European Space Agency, and Mr. Joël Barr, who is the Director General of the CSG.
Thank you, Jean-Yves. So, buon viaggio, Edoardo Amaldi. This is not yet a success of ESA. I shall say in 5 months from now if it's a success, because this is just the start of a very long journey which will take Edoardo Amaldi in space for the next 5 months. And it's a good start, very good start. And as you know, il faut partir à point. And I think that ATV3 has started at the right time, and it's on the right orbit. So this is a start of a long journey. There will be other critical phases, and the next one will be the deployment of the solar panels, which will be the first one in just 20 minutes from now. And then there will be other rendezvous, and especially the rendezvous which will take place on during the night, at least Paris time, during the night of the 28th to the 29th of March, with the docking of the ATV3 to the space station. And that rendezvous and docking will be controlled by the CNES Center in Toulouse. And then there will be other phases in the life of the ATV and until the re-entry, which will be another critical phase because obviously we have to control the re-entry of the ATV. So just to say that today it's not yet a success of ESA, Rendezvous in 5 months from now. But this is already a fantastic success for European industry because as I said this afternoon, building, integrating and launching an ATV every year, it's a fantastic achievement for European industry under the leadership of Astrium and especially as Jean-Yves has said, the start of the journey of ATV3, by the way, was starting in Bremen. And it's much longer from Bremen to Kourou than from Kourou to the space station. This is just the second step is much shorter than the first step. But so it's born in Bremen. And I would like to say that at the end, the 23rd of March is a good date for launch. I shall not tell you my statistics. 23rd is not the most fantastic date for launch. But 23rd of March, yes, it's a fantastic date because this is the 100th anniversary of the birthday of Wernher von Braun. So at least I was speaking of space pioneers this afternoon, and today is the birthday of Wernher von Braun, who has been instrumental, as you know, in all space journey. So I would like to thank, again, I shall start by the member states, because nothing is possible without the member states of ESA, who are making this type of event possible. And so thank you, the member states. But nothing would be possible either without the expertise and the dedication of several teams. Teams from industry, I have already mentioned that, and by the way, this is the same industry on Ariane and let's say the same leadership on Ariane and ATV, again, Astrium, but also the teams of Arianespace, and this is another success of Arianespace. At least for Arianespace, your work is completed. And thank you very much for this new beautiful launch. Thank you, CNES, especially at CSG. I must say that CSG is a fantastic place. And this is even more fantastic now with the 3 launchers in exploitation, with Ariane 5, Soyuz, and Vega. And thank all of you for sharing the emotion with us today. I would not like to forget 2 persons who have from ESA, who have contributing to this launch, but who unfortunately are not anymore here because they passed away. And I would like to have a thought for them, because they are still alive for us, because their work is now on its way. So thank you also to these 2 persons. But this is again a good step today. Since I am superstitious, I shall tell you about the deployment of the solar panels in a couple of minutes. But thank you very, very much, and especially thank you, Arianespace. Merci beaucoup.
Right, well, ladies and gentlemen, thank you very much for being here. And I'd just like to say that I'm very happy after having heard Mr. Legal and Mr. Dordan to say that we too, the CNES, feel very strongly about the success, even though for us the mission is not completed. First of all, at the CSG, we're going to now move on to the desorbiting of the upper stage of the launcher. This is going to be completed around 4 a.m. this morning. Those who are really brave can stay with us. You will be getting information on a regular basis. So this has to be done over the Pacific so that there is no debris left in space, and so that we have a complete and a clean mission. The mission will go on for us in CNES as well, in Toulouse particularly. That's where the ATV Control Center is. And the ATV Control Center will be working with the teams of the CNES, ESA and industry to deal with the guidance and the leading of the ATV up to the actual docking. Many different operations will be carried out between now and then. And then once again, once the docking has taken place and the ATV has completed its mission, it too will be deorbited and will drop over the Pacific Ocean. Now, once again this evening, we can say that we've seen something rather amazing and wonderful. Supplying the ISS, of course, is a vital step in space exploration. And therefore, we can say with great pride that it's happening here in French Guiana, South America, the Amazon. That's where we are. And this new success is, in fact, the highlight of the past 6 months of great success, where we have become a base from where 3 different launchers have been operating. Since September, in fact, there have been 4 very exciting launches. The first 2 Soyuz launches in October and in December, and then the first Vega launch in February. And all of these have been extremely successful. And now ATV3. So I too would like to thank many different people. First of all, the teams from ESA, from Arianespace, industry, and also Astrium, particularly. I think Astrium has been absolutely amazing, as they were the prime contractors of the launcher and the spacecraft. We'd also like to thank, and the satellite, we'd also like to thank the CNES teams here in Paris, the launcher division. They've all contributed to this beautiful launch today and to this big success. Thank you. Thank you very much. Now, I think some of you who are here in French Guiana will continue to participate, but the video transmission is going to end, and the next launch is going to be on the 15th of May, and we will be with GC-SAT 13 from Japan and Vinesat 2 for Vietnam. Thank you once again, or rather good morning, given the time, and see you soon.
We're going to go to a film on Arianespace and her family of 3 launchers now, all operational in French Guiana, and we'll be back with the European Space Agency part of the broadcast, the Arianespace portion, now finished. Don't go away. the end of the Arianespace mission, but we're in the continuing with the ESA portion of the broadcast. We are welcoming back Leo Aerts from ESA, who will be answering more of our questions. Leo, whom you saw in the interview that we had. Welcome back, Leo.
Thank you. Glad to be back with you.
We will have a couple of films also on from the ATVCC, the control center in Toulouse, and some other goodies for you. We have what we're doing is we're waiting for the solar panel deployment, which comes up when? That's in about 30 minutes, right?
30 minutes, yeah, I think so.
Now, why is that? That comes rather early in with the ATV, no? Because sometimes with satellites, it's take after 4 or 5 days after separation.
Well, usually you have to deploy the panels relatively early in the flight, otherwise you will not get the electrical power you need for the rest of the mission. But it depends on the vehicles, of course. But on the Soyuz, for instance, the Soyuz vehicle is immediately after the injection into orbit.
And the ATV needs a lot of power, I imagine.
Well, you need a lot of power, and continuously during 5 days or more until docking. And the ATV can stay also longer than 5 days if needed. So this, of course, all this is dependent on the electrical power and on the solar array deployment.
Okay, so that's what we're waiting for. In about 30 minutes, we should have confirmation of the deployment of the solar arrays. Before we get started, we have some questions for you. The quiz question that Luca asked you was, how many elements are there in the space station? Just wondering if anybody got that right. Maybe you can answer for us. How many elements, roughly, in the space station?
So this depends, of course, what we call elements.
And
but
who's counting?
The ones which were assembled, I think that's around 40 or 45 elements.
40 or 45 elements in the ISS. So anybody who got that answer right, give yourself a round of applause. And we'll let you maybe watch another launch replay or a film or something. So that was Arianespace quiz number 205. And I think Leo Aerts will send you, I think, his personal check for 205 euros if you've got the right answer. So you'll do that. He's promised to do it. Okay, can we look at some of the questions? I know you were a little bit, can I say, frustrated because in our interview down there, we didn't have a lot of time. And I know you like to talk about these things, and you wanted to go into detail about certain questions, and we didn't get enough detail. I share your opinion on that. We didn't have enough time, and we couldn't talk about everything that we wanted to talk about. So where would you like to start? You want to talk about, you flew on Mir and on ISS. Do you want to, would you like to compare them first?
Yeah,
Is that a good place to start?
Say a few words about that. So the first thing is that the ISS first is bigger and heavier than Mir. Is about twice the size and mass of Mir. So that's a big difference.
So Mir is what, half of a football field?
Yeah, in talking about the surface, that's about half, I would say, but it was a different architecture. So Mir was built in a form of a star, and whereas the station is more spread in space, it's more flat.
Mm-hmm.
Also, Mir was a purely Russian station.
Yeah.
And the ISS is the let's say the cooperation between 5 national agencies.
Do you or did you speak Russian?
Yep. When I was training for Mir, I learned Russian because we were working only in Russian. But this is also true on the ISS. When you train for the ISS, you have to you are trained both in English and in Russian when you are going to Moscow for the Russian side of the station and for the Soyuz.
And have you kept up your Russian? Do you still take lessons? Can you read it?
For a few years, I didn't practice a lot, but it comes back when you practice.
Well, the next time you fly, you're going to have to speak Russian, right?
Exactly.
So
I agree with you.
Okay, so Mir, smaller and older, of course.
And and the station does not exist anymore, Mir, because it was deorbited in 2001, I think.
Yeah.
One other thing we can say, the electrical power on Mir was much lower than on the space station, and that, of course, impacts the amount of activity that you can do on board. The space station, thanks to its great big solar arrays, deliver a lot of electrical power, and this, together with the organization of the scientific facilities inside, all this allows to do much more science in the ISS than on the Mir.
Back with more with Leo, but over to an interview now with Patrick Benaroche of the ATV Control Center in Toulouse.
The ATVCC
is the only place, and there are no other control centers anywhere in the world, where we can command, control, watch over, and direct the ATV vehicle. From here, we send all the commands to carry out the different actions pertaining to the ATV's mission. From here, we can also watch the ATV's behavior and the health of her different systems. Everything is centralized here at its Toulouse ATV Control Center with the different teams and under the flight director or directors. The ATVCC is operated by 4 different teams. These teams work in the 3 rooms which you can see behind me here. On my right is the flight dynamics team. They control the ATV's trajectory. On the other side of the main room, on my left, are technical experts. These experts are made up mostly of people who have built the ATV and who have an extended knowledge of its equipment and of its functions. In the middle is the main control room. Here there are 3 teams. The first, nearest the front, is the ground control. They are in charge of the preparation and operation of all ground equipment, including international communications to the US and to Russia. Behind them, all the way in the back, is the vehicle team, which has the responsibility of overseeing the vehicle, using the telemetry it sends to the ground, as well as sending commands up to the satellite. In the middle are the flight directors and their operational people, the ops managers. These people manage all the teams, the flight director being the one in charge overall of operations. On my right in this room is the mission director, who is the ESA representative. He holds what we call the mission authority. He makes decisions which can impact the ATV mission in case it must be shortened, for example, or if the ATV needs to consume more propellant, cases like that, in order to have the okay from ESA, who is the customer.
Well, we hope you enjoyed that interview with Patrick at the ATVCC. I think they're taking us live down there in Toulouse. The confirmation of solar panel deployment comes into Toulouse, I guess, huh? They're the ones that are going to be, because they're starting to, because they're picking up. We have another interview now with Isabelle Escan, who's the flight director, sitting right in the middle of the room. I think she'll be talking about the LEOPS, the low Earth orbit procedures. Back with more with Leo in a moment, but over to Isabelle Escani now.
After the vehicle has separated from the Ariane launcher, the ATV Control Center in Toulouse takes over operations for the next 6 months. The first operations involve configuring the ATV for phasing maneuvers. First, we wait for confirmation that its solar arrays have deployed correctly, so that the vehicle can recharge its batteries, and then switch on its systems, like, for example, the star sensors used to calculate and control its attitude, or the GPS receivers that provide the ATV's position. Over the next few days, the control center monitors and operates the vehicle continuously.
Les équipes vont se relayer en 3-8 pour
The teams work in 8-hour shifts to perform all planned operations on the ATV systems and the maneuvers to boost its altitude and to take it to the rendezvous point with the station. We also use this phase of the flight before arrival to test all the systems that will be employed during the rendezvous phase, like, for example, the collision avoidance and docking systems. Operations are planned and conducted in cooperation with the ISS control centers in Houston and Moscow. We're also in contact with the Columbus Control Center in Germany for network aspects. During the rendezvous phase, for example, representatives from Houston and Moscow are on hand at the Toulouse Control Center and ready to assist if necessary.
If you just joined us, you missed most of the action, but not to worry, there's plenty coming up. We're waiting for solar array deployment on the ATV. That should be coming up momentarily. We should be getting the word. Ariane 5 successfully delivered the ATV, and she's making her way up to the space station now. We're here with Leo Ertz again. We were talking about comparing the two space stations on which you've flown, ISS and Mir. We didn't get to crew conditions. How about the crew conditions? Anything to say there? Differences?
Yeah, and this is a big difference. The conditions on the ISS are much better in terms of crew quarters, the cabins where the crew can be, and also in terms of communications. On Mir, it was, for instance, very hard to communicate with the family, so you could talk to your family maybe once in a week or so. Whereas in the ISS, you can make phone calls whenever you want, almost, and you can also send emails, and they also have the internet today. So
yeah, they didn't have that with Mir, I guess.
Of course, it did not exist really at that time, but the crew is also able to talk and see his family every other week, every 2 weeks. So you have video conference with your family.
And when you have these video conferences, are you in a common room and the other astronauts are around you, or are you relatively private?
Usually it's private. So you go in a module where you're alone, and the other astronauts know it, so they leave you alone.
And you book time, or
and this is usually booked. And time is booked, yeah, because you also need satellite communications.
All right, sure.
So the loops are privatized. But this is a big improvement, especially when you have to spend 5 or 6 months in space.
Yeah, I imagine. How about debris avoidance? We didn't get a chance to talk about docking, really, during the interview. Would you like to talk about the docking procedures and what the crew do during docking, or do you want to talk about debris avoidance? Because you mentioned the propulsion aspect of the ATV, but we didn't really go into detail about debris avoidance. I hear you can see the applause there. You can see.
I think everything perfect now. ATV is where it is expected to be.
Yes, so far, yes. I think that there is power on board now, and when there is power, there is there is everything to work. So I think that it's a very good step. Not yet the end by far, but the launch, one step. The deployment of the solar panel, a second step. So I think that it's 2 good steps at start.
For ESA, it's really the illustration of the savoir-faire, the know-how, because when you think of what happened those last months between Soyuz, Vega, and now this, I mean, you must be a very happy Director General.
Yes. It's not only ESA, it's also all industry which is behind these three events. But it's true that the launch of Soyuz in October, the launch of Vega in February, the launch of today with Ariane 5 and ATV3. Yes, it's a fantastic 6 months, and because today the picture is very different compared to 6 months ago. Meaning that we are now a significant space power. I can say that.
Thank you.
Thank
you. Hearing from Jean-Jacques Dordain, a very happy man, a very full and satisfying 6 months with Soyuz Vega and now the ATV. I believe we had confirmation of the solar panels. We heard the applause. So that means that, what does that mean? We're in business.
That means now we have electrical power, which is the basic resource for the spacecraft to work. So that's great.
So not only has Ariane put the ATV in the proper position, but the ATV is functioning. Her solar panels have deployed perfectly. People here at the space base and, of course, at the ATV. No, the ATVCC. Too many letters at 6 in the morning. You know. Anyway, everybody's happy. Shall we continue? Debris avoidance, because we didn't talk about debris avoidance. It was another function of the ATV. Well, we'll get to that another time. Any last words? We have to say goodbye.
Well, great success for the ATV3, and it's his 5 months mission.
Over these last shots of the replay, we'll say goodbye after tonight's launch. 67 Ariane 5, 47 straight for the Ariane 5. If you count Soyuz and Vega, that makes 50 straight for Arianespace. Next launch of an Ariane 5 is May 15th. You heard Jean-Yves Le Gall say that. Vega's next flight at the end of the year. Until then, Joshua Jampel here on behalf of everybody here in the space base, my swimming buddy Luca Checchio and my friend Leo Aerts of ESA. We're all saying thank you for being with us. We hope you enjoyed it. We certainly did. We look forward to being with you next time. Goodbye, everybody.